Okay, question number 4. Calculate the molar mass of the following chemicals. Okay, so you have A, chlorine molecule, B, potassium hydroxide, C, BeCl2, and D, MgOH2. Okay, so from this molecule, you have to calculate the molar mass. So what you have to do is molar mass, you can get the number of atomic mass from the predict table. Okay, so A, you have Cl2, so meaning that you have two chlorine atom. Okay, so atomic mass from the predict table for chlorine is 35.45. So molar mass for the chlorines, you have to times 2 because of you have two molecule, two atom chlorine. So 35.45 times 2 equals to 70.9. So molar mass for chlorine is 70.9. B, potassium hydroxide. So atomic mass for potassium is 39.09 plus atomic mass for oxygen is 15.9 and atomic mass for hydrogen is 1. So when you total up, the answer is 55.99. Okay, for C, beryllium chloride. So atomic mass for beryllium is 9.01 plus 2 times. Why we put 2 here? Because of chlorine we have 2. So 2 times 35.45. So the answer is 79.91. Okay, and D, you have magnesium MgOH2. So magnesium, atomic mass for magnesium is 24.30 plus 2 times atomic mass for oxygen is 15.99 plus with 1 for hydrogen. Why put in front 2? Because of we have 2 oxygen and hydrogen atom. So when you total up, you will get 58.28. Okay. Right. Question 5. Find the percent composition of all the elements in the following compound. So you have to calculate the percentage composition of each element in this compound, meaning that you have to find percentage for copper. Example, for A, you have to find the percentage of copper and bromine. B, percentage of sodium, oxygen and hydrogen. And C, percentage for nitrogen, hydrogen and sulfide. Okay, so we look at the A first. So you have CuBr2. Okay, so Cu refer to copper, Br refer to the bromine. Okay, copper bromine. So first step, you have to calculate the molar mass for CuBr2. Okay, molar mass. So atomic mass for copper is 63.55 plus 2 times bromine is 79.90. So you get the answer is 223.35. Okay, so from this value of molar mass, so you can get the percentage of each element. So copper, you have one atom of copper. Okay, so for C, copper 63.55. Okay, atomic mass for copper, we divide with the molar mass of CuBr2, 223.35 times with 100. Okay, so you will get 28.45%. Okay, for bromine, so you have 159.8. Why 159.8? Because of we times the atomic mass for bromine with 2. Okay, so divide with 223.35 times 100. So you will get 71.5%. So when you total up the percentage of copper and bromine, you will get the 100%. So meaning that your answer is correct. Okay, next we look at the B. Percentage of sodium hydroxide. So first you calculate the molar mass of sodium hydroxide. Okay, sodium is 22.98 plus with oxygen is 15.99 plus 1. So the molar mass of sodium hydroxide is 39.97. Then you have to calculate the percentage of each element. So meaning that percentage of sodium hydroxide and hydrogen. So percentage of sodium equals to 22.98 divide with 39.97 times 100. So you will get 57.49%. Okay, for oxygen 15.99 divided with 39.97 times 100. The answer is 40%. And for hydrogen, 1 over 39.97 times 100 equals to 2.52%. Okay, so when you total up these three percentage value, so you will get 100%. So this one is a percentage for sodium, 40% percentage of oxygen, and 2.52 percentage for hydrogen. Okay, all right. Okay, for C we have in bracket NH4 to S. Okay, nitrogen, hydrogen, and sulfide. So again we have to calculate the molar mass first. Okay, so molar mass for nitrogen is 14, hydrogen is 1, and sulfur is 32.06. So when you total up, nitrogen 14 plus hydrogen 1 times 4. Okay, because of we have 4 hydrogen atom, so we put in bracket times 2. Because of we have 2 here, 2 molecule of NH4. Okay, plus with 32.06. So the total is 68.06. Okay. Okay, so percentage of nitrogen equals to 2 times 14 divided with 68.06. Why we times the 14 with 2? Because of we have 2 nitrogen atom here, times 100. So you get 40. 41.14%. Okay, and then for hydrogen, you have 4 times 2. We have 4 in bracket hydrogen atom. We have 4 hydrogen atom in bracket, and then outside the bracket we have 2. That's why we times 4 times 2 over 68.06 times 100. So the answer is 11.75%. And sulfur, 32.06 over 68.06 times 100. So you will get 47.11%. Okay. Alright. Finish for question 5. So we go to the next question. Okay. Question 6. You have to calculate A. How many molecules are there in 24 grams of FeF3? And B. How many grams are there in 2.3 times 10 to the power of 24 atoms of silver? So for this question, you have to come up with the formula. Okay, first one, you have to know the formula, how to calculate the number of molecules. Okay, so number of molecule equals to moles times Na. Na is the Avogadro number, and second formula is mole equals to mass over molar mass. Okay, molar mass or RAM, relative atomic mass. Okay, so we look at the question A first. How many molecules are there in 24 grams of FeF3? So from these questions, we have mass and the formula of FeF3. So meaning that we can calculate the molar mass for FeF3. So molar mass for FeF3 equals to, so atomic mass for Fe is 55.85. Okay, plus with 3 times 18.99. So you will get 112.82. Okay, so from the molar mass and mass, so you have molar mass and you have mass, you have molar mass and you have mass, meaning that we can get the moles. Okay, moles of FeF3. So moles equals to mass is 24 grams over molar mass is 112.82 grams. So you will get 0.212 moles. Okay, so bila you dah dapat moles, you boleh cari molecules. So you have times moles with Avogadro's number 6.02 times 10 to the power of 23. So meaning that the number of molecules of FeF3 is 1.3 times 10 to the power of 23 mole FeF3. Okay. Alright. B. How many grams? So meaning that you have to find the mass. Okay. How many grams are there in 2.3 times 10 to the power of 24 atoms of silver? Okay, so you have to calculate the mass of the silver. Okay, so you dah ada number of atom. Okay, 2.3 times 10 to the power of 24 atoms of silver. Okay, the symbol is AU. Okay, so from the formula, so you can get the moles. Okay, so number of molecules equals to moles times Avogadro number. So here we have atom, so you divide the 2.3 times 24 with the Avogadro's number 6.02 times 10 to the power of 23 to get the moles. Okay, so once you get the moles, you can times with molar mass. Molar mass of silver is 0.107.9 gram. Okay, so the answer is 410 gram. Alright,